Everyone, welcome back to SAT Math Question of the Day. Here's our question of the day. Please read it, try it out, pause the video, come back, and we'll try to do it. Okay, Sasha has 265 in her in change in her pocket. The 265 is made up of 1/4 and an equal number of nickels and dimes. Okay, how many nickels does Sasha have in her pocket? Seth's already going in there, and he's translating English into math. The 265 is equal to the quarter that's in her pocket, plus the same number n, where let n equal the number of nickels, and it's also equal to the same equal number of dimes that she has. So Seth's just solving it as quickly as he can, as we do on the SAT. Don't forget there's a calculator. So the answer is 240 divided by 0.15, and you don't have to do it in your head. It's 240 divided by 0.15, not 0.15, not 1.5, 0.15. Seth is doing it without a calculator. I'm going to be faster. That's impossible. 1600 is impossible. 2.4 divided by 0.15 is 16. Okay. 16 makes sense?
Yeah. 3, 1.
Right. Yeah. Right. Seth did 2.4 divided by 0.15 is 240 divided by 15. Yeah. Right. Yeah. So this is just a nice setup. Let n equal this number. The number of nickels. Let n is the number of nickels.
But also the number of nickels is the same as the number of dimes.
Right. So you could also let n be number of dimes.
Yeah.
N is the same.
But I chose n to be the variables. And I named it n because the question asks for the number of nickels.
Right. Yeah. So,
but notice that the contribution to the total from the nickels and the dimes is equal to, for each nickel, there's a dime.
Right.
And so the contribution for one nickel, since the number of dimes is equals the number of nickels, the contribution given the number is the value of the nickel plus the value of the dime. So you have to know a nickel is 5 cents and a dime is 10 cents.
Right. The other way to do these problems, which I sort of like, is go pennies, think pennies, work in pennies.
Just get rid of the decimal point.
Yeah. 265 means 265 pennies. 25 a quarter means 25 pennies. And a nickel is worth 5 pennies and a dime is worth 10 pennies. So that's n5 plus 10. And then you get rid of the decimal. And when you work in penny, when you have a problem in dollars, but the dollars are small, it's usually very advantageous to just work in pennies. So, okay, not much else to this problem. It's pretty standard. So, plural drawings, the answer was 16. We can also, you wouldn't have time to check this on the SAT, but you could certainly check this. Should we go through checking it?
No.
No? Okay. Then we'll just go here. Okay, 16. Okay, let's see how they answered this question. 4 steps, so it's not very many. Oh, they split it up. We know that, first of all, they worked in dollars, not in pennies. And they split up the 5 cents and the 10 cents into separate, into separate things, as opposed to X, 0.05 plus 0.1. But it's fine. It's fine to split it in separate. It doesn't take that much longer. And then you have to combine like terms, and then you solve, and then you go there. and then they show the answer. They show how to solve it. You divide both sides by 0.15. Yeah. Make sure your answer makes sense. Like when I first did it on my calculator, I got 1,600, some ridiculous number. That's because I didn't.
So she has, it's ridiculous. So she has 16 nickels.
Yeah.
Plus 16 dimes.
Right.
Plus 1/4.
Yeah.
In other words, she has 33 coins.
Yeah.
Could you, she must be, it's pretty heavy.
Well,
carrying around 33 coins in your pocket?
If she was at an arcade, and the arcade...
Yeah, but it's a special pocket then.
No. Yeah, I mean, if you're in an arcade...
That's a handful,
Yeah. Well, now arcades don't take money. They take credit, they take cards.
Oh, yeah.
Well, not much to this problem. And just a little bit of algebra. And a lot of translating English into math. And of course, it's a word problem, so you have to understand what's going on. In a big pocket, yeah. Big, heavy, strong pocket.
Yeah.
Okay. I guess
it should be better to say it's at her piggy bank.
Yeah. Oh, wow. I just realized today was Throwback Thursday.
Yeah.
And I never put the question on the whiteboard. So I'm going to have to draw it in, which I think I could do. So, anyway, today is Throwback Thursday. Throwback Thursday, we go back to a test that was given in the latter part of the last century, 1990s, sort of, maybe 1980s, 1990s, when the test had more questions that were more of intelligence type questions rather than just knowing what's on what you did in school. Post 2016, the SAT changed and put almost all the questions related to what you learned in school. But it was different back then. So let us see what we have here. We have to go to this thing called Ziteboard. And we will just find a piece of space. And we will clear the drawings. And this is the problem. And I'm going to have to draw it. Because I didn't copy it in. Ready? Okay, we have a picture of a triangle. It's a little off. It goes like this, sort of. It's not bad. It's a triangle, okay? And it's got all of its little things, all of its whatever these things, the sides extend out, okay? Now, we have, I'll do it in a smaller type style. We have this distance, this angle, this angle, this angle. It looks like all the exterior angles, doesn't it? This angle and this angle. Oh, they're all vertical angles, aren't they? Like they're all equal, aren't they? Yeah, I mean, no. I mean,
not the lower left two.
Oh, you're right. No, then I made a mistake. I caught myself. Okay, so they're all vertical angles. I mean, but if this is A, this is A. If this is B, this is B. If this is C, this is C. Okay, now, 3 lines intersect as shown in the figure here. What is the sum of the degree measures of the marked angles? In other words, what is A plus B plus C? Now, the choices are 360, 540, 720, 900, and cannot be determined. Back then, you had 5 answers, and they loved this cannot be determined back then, and I think only 18% of the people who answered this question got it correct. Seth looks confident.
Okay.
Seth looks
confident. I will apply a principle.
Go for it.
Which leads me to answer right away that it's 360. And what is it? What I do is I ignore one of the two pairs of vertical angles in each case. Right. And then, so what I'm remaining with is now the principle I'm going to describe has been called the total turtle turning theorem.
Oh my God. Okay.
And it goes like this. You have a turtle crawling along the edge of the polygon. And when he rounds the corner, he turns 8 degrees. He keeps going this way. He's headed this way, and then he turns the corner, and he turns another C degrees. So the total amount that he turned so far is A plus C.
Right.
Continues walking. Whoops, comes to the end of the triangle, and he turns B degrees. So by this time, his total turn is A plus C plus B. But he ends up pointing in the original direction. So so what we did was he turned, small, though less than a full circle, and he ended up in the same place. So the total amount that he turned was one full circle, which is 360 degrees.
Is that the
now,
same?
This principle is taught in school and is called the theorem of the exterior angles of a polygon.
Yeah, I was just going to ask: Is this
and the theorem that is taught is that not just for a triangle, but any polygon,
right, like a 5,
the sum of the exterior. The thing is, the exterior angles are defined by going only in one direction.
Got it.
So here we'll see. This is one exterior angle.
Wait, so you're going that way?
You were inconsistent in how you went.
I know.
You started out this way.
That's why I erased it.
So this is one exterior angle.
Right.
And then here's the next exterior angle.
Oh, so
and here's the next exterior angle.
You're starting to walk this way.
Yeah.
Right.
Yeah. And then this one is this way, and then this one is this way. So the sum of the theorem says that a different way of describing the same fact, the total turtle turning theorem, is the theorem that says the sum of the exterior angles in any polygon is a full circle, 360 degrees.
Yeah, I was wondering.
And I think you have to say simple polygon.
Okay.
That means when you traverse it, you don't cross. It doesn't cross itself.
Right. Right.
If you had someone making a polygonal path that went around like this and crossed itself, it could. The total turning is a lot.
Yeah.
It will be a multiple of 360 degrees.
Right.
Integer multiple 360 degrees.
Okay, so now I finally know how to understand exterior angles. Like if you go this way, this is the exterior angle because you're overshooting. The turtle overshoots, which means this way the turtle overshoots, so it's this one.
Yeah.
So you're inconsistent to call this an exterior angle and this an exterior angle, right? That's inconsistent. That's inconsistent. Got it. Okay, so I'll have to remember that. That in order to find the exterior angles, you pretend you're a turtle, or whatever you are, a rat or whatever you are, this way, you're turning this way. So that's the external angle, right? Then the turtle turns this way. And then the turtle turns this way. Got it. Okay, good. Now I have a better understanding. But isn't the answer really 720? Because they worded it. They said, what is the sum of the degree measures of the marked angles? So actually, you may have actually gotten it wrong.
Oh, the marked angles.
Yeah. Well, it's not your fault. You didn't have the writing, right? You didn't have the writing in front of you. So you may have read it better. You just heard what you wanted, but you didn't hear what the question was. The question actually was the marked angles. So you have to double it. Because they have all the angles are marked. You see,
Well, did the question...
Yeah, see it?
Did the question...
See it?
Let me finish. Did it say A, B, and C?
No, look at the question.
Oh, you put the A, B, and C in.
Yeah, I put the A, B, and C in, yeah.
Okay.
Yeah, that's the actual question, okay? So it's really not fair.
So that becomes ambiguous, you know, is it that there's one marked, are we computing the sum of the letters, which are the marks?
I'm taking out the A, okay? I'm taking out the thing. This is the way it was written. It was
okay.
Yeah. Now they're going to say the marked angles are the ones in the red arrow things.
Yeah, okay.
That is the sum. So the sum is 720. But you can't fault Seth for that because he didn't see the question. So only 18% of the people got that right back in the 1860s, the 1980s. And let's see if that is the answer. We always check just to be sure. So the answer sheet says 23C. All right. C. Yes, C is 720. Great. Okay. So this doesn't feel like a question they would have on the modern test. I mean, they could, but not likely. You don't really see things like this. But I mean, you're certainly going to want to know that the sum of the exterior angles of a polygon is 360. And then the formula for the sum of the interior angles of a polygon, which is n minus 2 times 180.
Can you derive the formula for the sum of the interior angles from the theorem about the sum of the exterior angles?
I probably could.
How do you do that?
I probably could, given enough time. But why don't you do it?
Well, I just need 3 seconds.
Okay, 3 seconds.
That's because I have a PhD in mathematics.
Fine. Okay.
It is because there are, if it's an n vertex polygon,
right. Seth's dying to do this.
Each exterior angle is the supplement of an interior angle, and the sum of a supplement and the angle is always 180 degrees.
Right.
And so what you do is add up the straight angles of 180 degrees for each vertex. So you have 180 degrees times the number of vertices is equal to the sum of the interior angles plus the sum of the exterior angles. The sum of the exterior angles is 360.
Oh, yeah. Right. Right. In other words, let's do the
So we have, I'll write it. So we have 180.
This way.
180
this way.
Times n.
This guy is
right?
This way.
Right. Plus
this way. So this one.
180 times n is equal to 360. Right. Plus the sum of the interior angles. Okay, so the sum of the interior angles is equal to sum of the ints is equal to 180 times the number of vertices minus 360.
So like in this problem, you're saying that A plus A prime, B plus B prime, C plus C prime, and D plus D prime have to equal 180 times 4 times
Yeah.
n, right? Right?
Yeah.
Because each of these
Yeah.
has to equal 180. So it's
Yeah.
A plus B plus C plus D plus A prime plus B prime plus C prime plus D prime has to equal n times 180. Well,
Yeah.
we know that these guys here sum to 360. Right?
That's it. Yeah.
So we know that the sum of the internal angles, which are these, equal 180 n minus 360, because these are added. See, not multiplied, this is added, right? Added to 360, right? Added to 360. So we factor out the 180 and we go n minus 2, and that's the sum of the internal angles. Very smart. Wow, cool.
Mm.
We did it. Generally, you memorize that. You don't derive that from scratch. But that's really cool. That's what the PhD in math gives you. So, who are we?
It gives you the privilege of remembering it in 3 seconds, as opposed to an indefinite prediction of time that you gave yourself.
Right. Yeah, I don't know how I would have done it. I would have figured it out, but I don't know how I would have done it. I only have a PhD in mechanical engineering. It's more practical, where I don't do this type of stuff. So anyway, who are we? I'm Joel. I have a PhD in mechanical engineering. Just said that, from Columbia University. Seth, brother Seth. He has my brother Seth. He has a PhD in math from MIT and has been teaching computer science at SUNY Albany for many years, but he's retired. He's now a professor emeritus. We are here. We have this YouTube channel and we have a website. And on the YouTube channel, we do a question a day where we try to offer different approaches on how to solve specific SAT math practice questions. So that's what we do. And in terms of studying for the Math SAT, we suggest you go to Khan Academy. They have 2 digital classes, two digital courses. We could have hundreds, 600, 700 questions in math, probably English as well, which is sanctioned by the SAT, which essentially tell you what is on the SAT, study those questions, and then go to the SAT and go to the SAT website and download some of their practice tests and do those as well. That's about it. So we meet every day. We try to meet every day. Okay. If you have any, please give us comments on our YouTube videos. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. And on Thursday, we do Throwback Thursdays. So that's about it.
Okay.
Right?
That's about it.
Okay. Thanks for that inspiration to figure out how to derive this. The key was the sum is equal to 180. Like that. See, being
and
the
that
engineer,
there are as many 180-degree angles there as there are vertices of the polygon.
right? But like all things in math, this thing all hinged on already proving that the sum of the exterior angles is 360. If you didn't already know that, then you wouldn't be able to do this. So one theorem helps another. And that's how it sort of works, right?
Right.
Yeah. Okay, everyone, have a great day. Take care.